Good morning. Here's your daily tech briefing for 2026-08-17. Today we're covering Java, Spring Boot, Redis, Kubernetes, and Cloud, AWS/Azure/GCP, plus the Architect's Corner. Let's get into it. Java, one of the most widely used programming languages, has been a staple in the development world for decades. Recently, there's been a growing interest in making Java more accessible and easier to use, especially for smaller projects and beginners. This is where JBang comes in, a relatively new tool that's been gaining traction in the Java community. JBang is essentially a command line tool that allows you to run Java code without the need for a full-fledged Java development environment. It's often compared to tools like Python's pip or Node's npm, but for Java. The idea behind JBang is to make it easy to get started with Java, even if you're not planning on building a large-scale application. With JBang, you can write and run Java code in a matter of seconds, without having to worry about setting up a complex project structure or dealing with build tools like Maven or Gradle. The article on Sombrix.com BR blog highlights the potential of JBang in taking Java from small to big. The author discusses how JBang can be used to start small, with simple scripts and experiments, and then gradually scale up to larger projects. This approach can be particularly useful for developers who are new to Java or want to quickly test an idea without investing too much time and effort. One of the key benefits of JBang is its ability to simplify the Java development process. By providing a straightforward way to run Java code, JBang makes it easier for developers to focus on writing code rather than setting up their environment. This can be a huge time saver, especially for smaller projects or proof of concepts. Additionally, JBang can also be used to teach Java to beginners, as it provides a gentle learning curve and allows students to get started with Java quickly. While JBang is still a relatively new tool, it has the potential to make a significant impact on the Java community. By making Java more accessible and easier to use, JBang can help attract new developers to the language and make it more competitive with other programming languages like Python or JavaScript. As the Java ecosystem continues to evolve, it will be interesting to see how JBang fits into the larger picture and how it can be used to support the development of larger, more complex applications. The article provides a detailed overview of how to get started with JBang, including installation instructions and examples of how to use it. It also discusses some of the limitations and potential drawbacks of using JBang, such as the lack of support for certain Java features. Overall, the article provides a comprehensive introduction to JBang and its potential to simplify Java development. It's worth noting that JBang is still an emerging tool, and its adoption is not yet widespread. However, as more developers begin to explore its capabilities, it's likely that we'll see more interest in using JBang for both small and large-scale Java projects. As the Java community continues to grow and evolve, tools like JBang will play an important role in shaping the future of Java development. If you're working with Spring Boot, you know how complex and sometimes tricky it can be to manage the startup process and bean cycles in your application. Recently, a developer introduced a new tool called WireDoctor, which is designed to help simplify this process. WireDoctor is a Spring Boot startup and bean cycle analyzer, and it's now available on GitHub. The creator of WireDoctor, who shared it on Hacker News, aimed to provide a tool that could help developers visualize and understand the relationships between different beans in their Spring Boot application. This can be particularly useful when you're working on a large and complex project, and it's not always easy to see how different components are interacting with each other. WireDoctor is built on top of the Spring Boot framework, and it uses a graphical interface to display the bean cycles and dependencies in your application. This can help you identify potential issues, such as circular dependencies, and make it easier to debug your application. The tool also provides detailed information about each bean, including its dependencies, scope, and lifecycle. One of the key benefits of WireDoctor is that it can help you optimize the performance of your Spring Boot application. By analyzing the bean cycles and dependencies, you can identify areas where your application may be wasting resources or experiencing bottlenecks. This can help you streamline your application and improve its overall efficiency. Another advantage of WireDoctor is that it's highly customizable. The tool allows you to configure the level of detail that you want to see, so you can focus on the specific areas of your application that are most relevant to your needs. This makes it a valuable resource for developers who are working on complex Spring Boot projects and need a deeper understanding of how their application is working. While WireDoctor is still a relatively new tool, it has the potential to be a game changer for Spring Boot developers. By providing a clear and visual representation of the bean cycles and dependencies in your application, it can help you build more efficient, scalable, and reliable software systems. If you're working with Spring Boot, it's definitely worth checking out WireDoctor to see how it can help you improve your development workflow. The tool is open source and available on GitHub, so you can download it and start using it right away. Let's dive into some interesting news about Redis, a popular in-memory data store used by many applications for its high performance and low latency. If you're not familiar with Redis, it's essentially a database that stores data in the computer's RAM or random access memory instead of on disk, which makes it much faster for certain types of operations. Recently, a project called Nibble caught our attention, which is related to optimizing Redis memory usage. The creator of Nibble, Ryan Rana, observed that Redis often uses less RAM than initially thought, and this project aims to measure and apply this insight to optimize memory allocation. Nibble is an open-source tool available on GitHub, and it's designed to help Redis users understand and potentially reduce their memory footprint. The idea behind Nibble is to provide a more accurate measurement of how much memory Redis is actually using, rather than relying on rough estimates or Redis's own reported memory usage. By doing so, Nibble can help identify opportunities to optimize memory allocation, which can be particularly important in environments where RAM is limited or expensive, such as in cloud computing or containerized applications. For example, if you're running a Redis instance in a container, you might allocate a certain amount of memory to that container based on your expectations of how much memory Redis will use. But if Redis is actually using less memory than you thought, you could potentially reduce the amount of memory allocated to that container, which could help reduce costs or free up resources for other applications. The Nibble project is still relatively new, with only a few comments and points on Hacker News, but it's an interesting development that could have practical implications for anyone using Redis in their applications. By providing a more accurate measurement of Redis memory usage, Nibble could help engineers optimize their Redis configurations and make more efficient use of their resources. We'll be keeping an eye on this project to see how it develops and whether it gains traction in the Redis community. It's also worth noting that optimizing memory usage is an ongoing challenge in software development, and tools like Nibble can be an important part of that effort. As applications and datasets continue to grow in size and complexity, finding ways to use memory more efficiently will become increasingly important, and projects like Nibble can help pave the way for more efficient and scalable software systems. Kubernetes has been gaining popularity in recent years, and it's not uncommon to see engineers experimenting with it in their home labs. A recent video posted on YouTube, titled "Destroying My Home Lab with Kubernetes" by the Linux Society UNSW, has caught the attention of the tech community, with 8 points and 1 comment on Hacker News. In this video, the presenter shares their experience of setting up a Kubernetes cluster in their home lab and the challenges they faced along the way. For those who may not be familiar, Kubernetes is an open-source container orchestration system that automates the deployment, scaling, and management of containerized applications. It's a complex system that requires a good understanding of networking, storage, and security. The presenter starts by explaining how they set up their home lab, which consists of a few machines running Linux, and then proceeds to install Kubernetes on them. They use a tool called Kubedem, which is a popular choice for setting up Kubernetes clusters on bare metal machines. As they progress through the setup process, they encounter several issues, including networking problems and node failures. What's interesting about this video is that it highlights the complexities of setting up and managing a Kubernetes cluster, even in a small home lab environment. The presenter shares their thought process and troubleshooting steps, which provides valuable insights for anyone who's looking to set up their own Kubernetes cluster. They also discuss some of the common pitfalls and mistakes that can be made during the setup process and how to avoid them. The video is not just about the technical aspects of setting up Kubernetes, but also about the presenter's personal experience and lessons learned. They share their frustrations and disappointments, as well as their successes and achievements. This makes the video more relatable and engaging, especially for those who have gone through similar experiences. For engineers who are looking to experiment with Kubernetes in their own home labs, this video provides a realistic view of what to expect. It's not a straightforward process, and there will be challenges and setbacks along the way. However, with persistence and patience, it's possible to set up a fully functional Kubernetes cluster, even in a small home lab environment. The video is definitely worth watching for anyone who's interested in Kubernetes and wants to learn from someone else's experience. Google has just announced the rollout of Release 6.398 for its Google SecOps Security Orchestration, Automation and Response, or SOAR, solution. For those who might not be familiar, SOAR is a security tool that helps automate and streamline incident response processes, making it easier for security teams to respond to threats. This new release is part of a gradual rollout, which means it's being introduced in phases, starting with a select group of regions. You can find the full list of regions included in this initial phase on the Google Cloud documentation website. This release focuses on addressing internal and customer-reported bugs, which is essential for ensuring the stability and reliability of the SOAR platform. By fixing these bugs, Google is aiming to provide a smoother experience for its users and prevent potential issues that could disrupt their security operations. While the announcement doesn't go into specific details about the bugs that were fixed, it's likely that they were affecting the performance, functionality, or integration of the SOAR solution with other Google Cloud services. The gradual rollout approach allows Google to test and validate the new release in a controlled environment before making it widely available. This helps to minimize the risk of introducing new issues or disrupting existing workflows. As a result, users in the initial phase of regions can expect to see the updates first, while others will need to wait until the rollout is completed. For companies and projects that rely on Google SecOps SOAR, this release is an important update. It demonstrates Google's commitment to continuously improving and refining its security tools to meet the evolving needs of its customers. By addressing bugs and enhancing the overall quality of the SOAR platform, Google is helping its users to better respond to security threats and protect their assets. If you're using Google SecOps SOAR, it's a good idea to check the documentation and release notes for more information on what's changed and how it might impact your workflows. Now, let's shift gears for the Architect's Corner, 5 minutes on real enterprise software architecture and system design. The problem of tracking vehicles at scale is a complex one, especially in a country like India, where the logistics market is highly fragmented. Bosch Mobility Platform Solutions faced this challenge head-on when they set out to build LOS, a vehicle tracking platform that could unify the market into a single real-time visibility layer. The team had to design a system that could handle a large volume of location data from thousands of vehicles, process it in real time, and provide accurate tracking information to stakeholders. This was no easy task, given the sheer scale of the problem and the need for high availability and reliability. To solve this problem, the Bosch team turned to a serverless architecture on Amazon Web Services, or AWS. They chose to use Amazon ECS, AWS Lambda, and Amazon MSK to build a highly scalable and fault-tolerant system. The team started by designing a data ingestion pipeline that could handle the high volume of location data from vehicles. They used Amazon MSK, a managed streaming service, to collect and process the data in real time. MSK allowed them to handle high throughput and provide low-latency data processing, which was critical for real-time tracking. The team then used AWS Lambda to process the data and perform tasks such as geofencing, route optimization, and anomaly detection. Lambda's serverless nature allowed the team to scale their processing power up or down as needed, without having to worry about provisioning or managing servers. This not only reduced costs, but also improved the overall efficiency of the system. To manage the state of the vehicles and provide a unified view of the logistics market, the team used Amazon ECS to deploy and manage containerized applications. ECS provided a highly available and scalable platform for the team to deploy their applications, and its integration with other AWS services made it easy to manage and monitor the system. So why does this matter to enterprise software architects? The Bosch LOS platform is a great example of how a serverless architecture can be used to build highly scalable and fault-tolerant systems. By leveraging AWS services such as MSK, Lambda, and ECS, the team was able to focus on building the business logic of their application, rather than worrying about the underlying infrastructure. This approach allowed them to quickly deploy and test their system, and make changes as needed without affecting the overall availability of the platform. The use of serverless architecture also reduced costs and improved efficiency, as the team only paid for the resources they used. One key takeaway from this case study is the importance of choosing the right architecture for the problem you're trying to solve. In this case, a serverless architecture was a good fit because it allowed the team to scale their system up or down as needed and provided high availability and reliability. However, this approach may not be suitable for all use cases, and architects should carefully consider their options before making a decision. Additionally, the use of managed services such as MSK and ECS can simplify the process of building and deploying complex systems, but it's still important to have a deep understanding of the underlying technology and how it works. The Bosch LOS platform also highlights the importance of real-time data processing and analytics in modern enterprise systems. As the amount of data being generated by vehicles and other devices continues to grow, the need for systems that can process and analyze this data in real time will become increasingly important. Architects should be thinking about how they can design their systems to handle high-volume, high-velocity data streams, and how they can use technologies such as streaming services and serverless computing to build scalable and efficient systems. By studying the design and architecture of the Bosch LOS platform, architects can gain valuable insights into how to build their own highly scalable and fault-tolerant systems, and how to leverage the latest technologies to drive business innovation and growth. And that's your briefing for today. See you tomorrow morning.